let's see. Two parts that should trip people up sometimes are finding the z-score and then putting this in the calculator correctly. So I tell you everything. What's x bar? 16.4. What's sigma? 2.5. Why is it sigma, not s? Beautiful. So later today we're going to learn what to do if I only know s. I'm going to have to change something here. N is, so why is it okay to use z-scores here?
Because it's
Normal, that's why I'm able to use the chart to convert to z-scores. How do you find z? Well, if you do it the old-fashioned way, no, you look up, there's 95%. So what's out here? 0.025. And we look up 0.025, what do you guys get? 1.96, I like it. So what's z? 1.96. Why do I not give a shit about the negative or the positive? Because that's where? It's built in. The formula has it because the formula is based on going up and down. So now it's just plug and chug. Now remind you guys, scheisse. Jeff didn't have the z-score for it. Z-score chart. Oh well, if you look at the z-score chart, there's that little baby chart. Yeah. Darn it. I don't have any z-score charts left. Too bad, Jeff. Anyway, if you don't understand, just do this chart. Now, plug and shove. 68.4, give or take, this many steps. What do you guys get for the error? Yeah, I like it. So 68.4, give or take 0.806. That's fine. Then I'm going to do my weird little shit. You don't have to do it. 68.4 minus that, 68.4 plus that, and I get this. 67.6 up to 69.2. Is that good up to there? So that's the nuts and bolts of it. Are you guys okay? I love how some of you are like, I'm not going to tell you how I am. That's my business. All right, shit. Conclusion. We are what? Yeah, 95% confident that what? The interval. Real quick, this should seem silly to some of you guys. How many intervals are on this? Have I created? How many intervals have I created? One. Of course, it's got two sides to it. That's why it's an interval. Don't say intervals. There's only one. I know there's a little pet peeve, but I don't care. There's one little interval there. The interval, what to what?
67.6.
There you go. Somebody saved your asses from me being all yards. God damn, that's a big dude. That the interval this to this does what? Contains, you could say captures, contains the true, mean what? Height of men. Man. Boring sequel to City of Men. True mean height of men. Okay. How does everybody feel about that? The worst thing I could do to you in this kind of a problem is give you a list of data and you have to calculate your own X bar instead of me just telling you what it was. And is that bad? No. Just throw it in one bar stats and do it. Right? That's how you get X bar. If I give you a list. Here, I just told you what X bar was. Or I can give you a list and you just throw it in the old calculator. And get the X bar, yeah. Yeah. Everything else I got to tell you. Okay. Now, let's talk about part B. Where the shit did that come from? Let me see. Is there something I can use left over? Yes. No. Yes. It's a roller coaster of emotions. There we go. All right. Now, to figure out this part B. Whoa, extra shit. Let me write this down. What part of this was the error? Good. So the error is this. So let me write that down. The error is this. So how far off were we? We were off by 0.806 inches. It's pretty good. What could I immediately change if I'm the one that did this study that would make the error smaller? All right, so say I still need to make a 95% confidence interval for my boss. That's what my boss wants. But if I wanted this error to be less, I want this error to be smaller. Look mathematically. Can I change Z? No, I just said I want 95%. You can't change that shit. Can I change sigma? No, you'd have to go around and stretch every guy out maybe, and then you change the standard deviation of heights. So that's probably unethical. So what can you change? Yeah, the sample size. If I make n bigger, what happens to the error? Divide by bigger so it gets smaller. Doesn't that make sense? The first day we would have known that. How do you make a better sample? How do you know more that you're closer to the right answer? You make your sample bigger. So then your error should get smaller. Holy shit. So there will be questions that will say, I want to be this close. I want my error to be this small. How big of a sample do I need? And that's called a feasibility study. If I need my sample to be 80,000 people and I am the one doing the study, am I going to go talk to him? No. I'm like, well, screw that then. I just can't get that close. Too bad for me. So part B needs a formula. How many? It needs a formula solved for n. So just take this and solve it for n. And I don't know if you guys remember, but this is on the, pretty sure it was on the warm-up sheet that we did a million years ago. How do I solve this for n? Where is n? There, that really sucks. It sucks doubly over. It's on the bottom and it's in the square root. Shit. Good. Swap these two out. Remember that? I can multiply by this and divide by this. So then they just change places. Okay, I like it. There's a lot of algebra that looks funky as shit when you write it with letters. But it's stuff. 10 divided by 5 is 2. So of course 10 divided by 2 is 5. You just switch those. 10 divided by one chunk is the other chunk. We know that shit. That's all I just did. And then what's the last thing I got to do? Turbo sets. Yeah. So I get this. That's where this comes from. See, when you see a question that says, how many? Oh, then I need a formula solved for n. Because that's what how many means. At 95% confidence. So Z is still going to be what? 1.96. Sigma is still 2.5. And E is how close I am, how far off I am. So what's E in part B? Now watch this. The big mistake is somebody puts 0.806 in there because the brain is like, well, that's what the error was, but I'm on a different problem. If you put 0.806 in here, you're going to get frickin' 37.
Yeah, I just.
Because look. 37 dudes will lead to an error of 0.806. So if you put 0.806 in here, you're going to get 37. You already knew that shit. I want to make the error 0.5. So am I going to need more dudes or less dudes? More dudes to be less error, right? So put 0.5 down here and square it. Don't forget to square this shit. So let's see if you can put it on the calculator correctly. You could do it this way too. Square everything, since everything's squared. All right, that's how I normally do it. I do this. 1.96 times 2.5 divided by 0.5. Enter, squared, enter. Because everything's got to be squared. Are you guys semi with me? Or however you put it in, you should be getting this. So that means to be within 0.5 inches, I need 96.04 men. Can I do that? No. Why is it wrong to make it 96 men? I'm not going to be within 0.5 anymore. I've got to have that much at least. So you always do what? You always round up to make it a whole number. So you're going to take 97 dudes. So I get 96.04, but then I round up to 97 because I don't want to have to chop off the tip of some dude's nose or something. Yeah, now I got 0.04. Let me stop for a second. Oh. But see, this is, to me, and I know I'm weird, obviously. I'm a math teacher. But to me, this is so freaking awesome that you have, statistics is beautiful because your formulas are always one step away from the idea behind them, always. Most formulas are, but statistics is really in your face. So I know this is the error piece. Algebra tells me how to rewrite this formula so that if I know what I want the error to be, I can figure out how big my sample has to be. Now, is this manageable? 97? Yeah, of course, that's fine. If it would have been 97 million, maybe not, boss. We can't be within that much, boss. Can't make it happen. Okay, now you're going to be excited about this next part. Oh, shit. So I kind of talked about this way earlier this semester, like at least a week or two ago, that you see confidence intervals when you look at how people are going to vote. 44% for this guy, 42% for this woman, and at the bottom it's plus or minus something. So that's the plus or minus shit. We just haven't made confidence interval yet for percentages. So that's what we're going to do next. And guess where we're going to start? The same place we started before. What you got, Jeff? So remember, this is where we started. Then we made this X bar. We changed that to sigma, squared, all that kind of shit. So we're going to start here again. Makes sense. Okay, now, let me do one little thing. So, let's see if you guys are cool with this. So, okay. If I'm trying to figure out the percentage that like lima beans, what percentage of gross month students like lima beans? Because this is a thing we need to know. There is some true percentage, right? This is going to be the population percentage. Sort of like mu is the population mean, and then when I take a sample, I find X bar. So the first thing I gotta realize is I need some kind of a different symbol for a sample percentage. P is the population percentage. You're gonna love this shit. The sample mean has a bar on it, right? It gets to wear a little bar on its head. Okay. So anywhere it goes, it's got a bar. So if we take P and we put a hat on it, P hat. Sounds like something you don't want to wear, but don't wear that. It's P hat. This is the sample percentage. Bless you. It's pretty decent with that. Same idea with mu, population mean, X bar, sample mean. P, population percentage, P hat, sample percentage. That's it.
Why do we change it from X bar?
Oh, okay. So the first thing I'm going to do is I'm going to bring that back in. Ready? All right. So I don't know the real mean in general. Let me take one step and then I'm going to start sucking the P stuff in here. That sounded terrible. What do I do with my confidence interval? I try to estimate what the mean is. I love you guys. So that means I try to use the interval to estimate what the real mean is. What's the formula for the mean for an NPQ problem? Oh, I gotta use blue, it's better. What's the formula for the mean for an NPQ problem? That's the standard deviation. So we're gonna need that. Let me put that down here. What's the formula for the mean? NP. So what do you think the formula for the sample mean is? NP hat. I love it. See how your gut is correct? All right. Not always. Be careful. Especially not politics. So NP hat. So what do you think the standard deviation is going to be? NP hat, Q hat. So let's plug that shit in. So again, I start with the basic idea, but then I throw shit in that's specific to what I'm dealing with. So I replace X bar with NP hat. Let me at the same time replace mu with NP. Give or take Z times the square root of NP Q hat. NP hat Q hat. Now when I create a confidence interval for percentages, I want to estimate the real percentage. Right now I'm estimating NP. What do I want to get rid of? I want to estimate the real percentage. I want to get a feel for what the real percentage of people that like lima beans is. What's there that shouldn't be there? Right now I'm estimating N times P. I want to estimate percentage. So I want to get rid of N. So let's get rid of N. So P is approximated by this interval. I love you guys. By the way, you should be able to identify now in this class. We're in the derivation part of the lecture, right? I'm showing you where a formula comes from that we are going to use. It's my hope that some of this, if not all of it, makes some kind of sense. But if it makes zero sense, you're not dead. We're going to get to the formula you're going to use, and you can use a formula. That's great. But hopefully some of what we're doing makes a little tiny sense. All right. So I get, this makes sense. My sample percent, give or take this shit. So that looks just like the sample mean, give or take something. This is the sample percentage, give or take something. And it's going to build a confidence interval for a percentage. Is that cool? Because what was it? It was X bar plus or minus shit. That's the confidence interval for the real mean. So I want the confidence interval for the real percentage. It better be a percentage, give or take shit. Now, some of you guys are like, yeah, shit. Now, there is one thing I can do with this. Can I kill the N's?
No.
Of course not. Of course you can tell by the way I asked that. Why not? Why can't I just do, there's an N on top and an N on the bottom? What I just said is wrong though. Is there a full N on the top? No, there's like a half an N. So you can only divide two things if their roots are the same. Do you guys remember that? Square root of 10 divided by square root of 2 is square root of 5. Kick ass. Half of 10 divided by half of 2 is half of 5. We've been doing that forever. What's 8 divided by 4? Why are you allowed to do that? Because they both have the same root. None. So the only way you can divide two things is if they have the same root on them. What is N equal to the square root of? What can I replace this with? Square root of? What is N equal to the square root of? 5 is equal to the square root of what? Square root of 5 is not 5. 5 is equal to the square root of 25, which is 5 squared. 7 is equal to the square root of 49, which is 7 squared. N is equal to the square root of N squared. I love you guys so much. Why the shit am I doing this? Because of what I just said. I want to be able to do something with this. But I can't because they don't have the same root. Okay, give the dude on the bottom a root. Shit. But the only way to do that legally, if I cut it in half, I better double it. You square it so that overall it's the same. So now what can I do? I can kill an n, right? One n dies. So then I can write this piece as z. Right. Square root p hat q hat over n. So notice how both formulas are what I see in my sample, give or take, some number of steps. For a mean, it looks like this. This is what we're very used to. For a percentage, now we know what the standard deviation looks like. Holy shit. For a sample.
You're just going to read the whole thing. Or use the problem.
No, because remember I had to put a square root on this dude, right? So there's one big ass square root over everything because everything's cut in half now. All right, like it. So if you look at this number 2, as I kill myself, there's the formula. All right. Yes, ma'am.
So, just to get it straight, the very top one was what we learned like the first week.
A
Right?
million years ago, yes.
Yeah.
Or
And then-
2 weeks.
And then you go down to the second one, and that's when we did the.
And
Because
from
if we
here,
don't know the
from here, we branched off to do this, because I replaced this with what it has to become. Or I can branch off this way if I want to get percentages in there. But this idea is independent of what I want to do with it next. This idea exists. Then I can do shit with it. And that's a really weird thing to realize about math, but that's the beauty of math. You have an idea that connects these things. And you can put whatever specific things for whatever situation, and it still has to be true, because the idea is true. It's craziness. Now what I just said isn't, I can throw whatever I want to into something, it's great. No, that's not what I said. But there's an idea that has several different looks to it based on the situation I'm in. And if I'm in a means, if I'm trying to figure out a composite for means, that's what it's going to look like. Percentages, that's what it's going to look like. So what people do is they pick the wrong formula to use. But if the problem says, find a confidence interval for the true percentage, I'm going to use the one that's got frickin' percentages in it, right? Don't tell me I don't know sigma, so I can't do it. No, you don't have to know sigma. It's percentages. So let's do this one together. This number 2 here. Now this is what kind of makes me sad is, if I just said I got 652 people I talked to and 316 of them voted, what percentage voted? How do I figure out what percentage voted?
316 divided by 652.
Yes, 316 out of 652. And that's something that's not as well understood anymore nowadays, coming out of high school. It makes me sad, but oh well. I'm not saying it's your fault, I'm just saying it's happened. And what is 316 divided by 652? 0.4847? So that's P hat. And the beautiful thing about P and Q, I don't care what kind of clothing they're wearing, they always have to add the B 1. So P sock plus Q sock has to be 1, P bar plus Q bar, whatever. So what's Q hat have to be?
5.5.
Beautiful. Make it 9, make it 9, make it 9, make it 10, 5, 1, 5, 3. Or 1 minus that in the calculator. What do you do? And what's N?
216.
Careful.
652.
There you go. 652. N is always the total number. Do you notice what 316 is? It's the number of successes. Remember X was the number of successes? That's why it's up there. N is the total number of people I talked to or things that I looked at. Okay, hopeful. Oh, okay, all right. Okay. I gotta turn you around in a second. I always forget this is coming. Do you see how where it says check those? It's like, what the shit? Okay, here we go. I promised you before. What do I check if it's a means? What do I check to make sure that I can use z-scores from percentages? What has to be true before I can use a z-score chart? It has to be normal. And either I say it's normal or what saves your ass if I don't say it's normal? Number. What about number?
Greater than 30.
Greater than 30. I love it. That's for means. I like that reaction. For percentages, it's going to be a little different. Let me try to show you why. This goes back to that one handout I had. Oh, there it is. This here. Doesn't that look really normal? Because it's symmetric, right? And all that kind of stuff. So now, watch this. Just remind you, I'm about to go into derivation mode. I'm going to show you the idea behind what we do. And then what we actually do is going to be two quick little things. Let me ask you this. What if I had that same situation? I don't know if you guys remember, this was 14 times I was tossing a coin, flipping a coin. But let's say that it's weighted so that P is 0.1. You with me? What would the mean be then? NP? 1.4, right? So then there's no way this thing could be normally distributed. It's dead. Because there's a wall here that's 0. There's another wall that's 14. That's the smallest and biggest this thing could be. It's got to live within those two things, right? Where's the highest bar going to be? Freaking down here. So it's going to start high and then go low. I mean, does that look normal? No. So, you have the same problem on the other side. Let me ask you this. Let's see if you guys can get this. So does it make sense then that this it's got to be true? Do you remember this book if it says greater than or equal to? Some books say that, or some books, let me just say greater than. If n times p was 5, so what's wrong with this? Why is this not normal? It doesn't have room to go up and come back down. Do you guys see that? Because the mean is so small, it's right on the 0 wall. It doesn't have room like that one does. That one's mean is 7. It's got room to go up and then come back down. So NP has to be at least 5. So it's got room to come up, grow up to 5, and then shrink back down after 5. NP's got to be at least 5. Okay, just to kind of cut to the chase here. The other side is like the failures, and the failures have to be at least 5 also. NP being greater than or equal to 5 says stay away from that wall, and Q being greater than 5 says stay away from that wall. Because if the mean was too big, it was up here, it would still not look normal, right? It looks skewed to the left now. So the mean has got to be in the middle somewhere, so that it's got room to go up to it and come back down from it like it does up there. So both of these together say, stay away from that wall, stay away from that wall, be in the middle so you got room to go up and come down. As long as it does this, it's normally distributed. So that is normally distributed because NP and NQ are both 7, bigger than 5. So this is exactly like n greater than 30, but that works for means. Now that we're talking about percentages, this is what I have to check. And again, just remember that all this check does is stay away from this wall, stay away from this wall, so that you have room to go up and then come back down. Otherwise, you ain't got no chance to be normal. Showing off my grammatical skills. So, Look what this chart says. Why does it say NP hat and NQ hat? Because we don't know what the frick P and the Q are, so we use the best guess. Some of you guys will realize what I'm about to say. Good Lord, Jeff. How did I get P hat? I did 316 divided by 652, right? So what is N times P hat gonna have to be? You guys see that? What is N times P hat? It has to be 316. So I don't have to do 0.4847. If you did it, what is 0.4847 times 652? What was it, 652? Yeah, basically 316. Why is it not exactly 316? Because we rounded P hat, didn't we? So some of you guys are going to do all that work, and some of you guys are going to just realize, well, that's 316. And what's this got to be? The rest. So it's going to be 652 minus 316. It's going to be 336. So is this normal enough? Why? Because those are both way bigger than 5. Check. What does that mean? I can do something. If that wasn't true, I can't do shit in Stats 1. Stats 2, you can do shit, but you have to take that at university. Stats 1, we got to say we can't do shit. But here I can do shit. It's way bigger than 5. It's totally normal enough. So I'm allowed to look up a z-score. How confident do I want to be? Now I'm being a little bit evil. 91%. Okay, let's draw that. So what's in here? 0.91. So what's out here? 0.045. I like it. So then you have to look up 0.045. You can't use a little baby chart. It's a little baby chart. It only knows certain things. You got to look up 0.045. So you know on a test, I'm going to ask you to make like the 87% confidence interval. Because I am evil. You haven't accepted that fact yet. I'm not sure what else I have to do. Or maybe because it's good to know. That might be too. I don't have my z-score chart anymore, damn it. Yes?
So with the, going back to the MP and NQ,
Yes.
it's like the averages of people that are gonna vote.
Yeah, NP would be the expected number of people, and that's equal to what we saw, because that's our best guess. What's our best guess for the expected number of people? Well, 316, because that's what we saw. And this would be the expected number of people that didn't vote in the primary. So
And that's like,
good.
that's a number of